Hey everybody, Mr. Height here. I am gone today. So I wanted to go over today and what we're going to be learning. First, we're going to do a quick warm-up in our notebooks. So if you don't have your notebook, go get it. All right, I hope you got it. All right, so this is going to be on page 89. And we're going to be comparing oil versus water. All right, after that, I'm going to have you watch a short video titled Everything is Made of Atoms. After that, I'm going to show you this atomic zoom in. After that, and for the most of today's lesson, you're going to be reading and annotating an article called Atomic Zoom In. And then there's a couple of summary questions at the end. You're going to turn all this in at the end of this hour. You should have plenty of time to get everything done today. All right, so for our warm-up, I want you to go to page 89. The date today is 3/27. I want you to title it Oil and Water. Make a T-chart. So on your T-chart, on the left side, I want you to write water. And on the right side, I want you to write oil. And you could draw a picture. I'm going to draw a picture. I got some water. I got some oil. And this is like, think of oil as like cooking oil that you might find in a kitchen, or like olive oil. And with these two, and on the T-chart, I want us to remember what a property is. So a property is any characteristic that can be measured, such as an object's density, color, mass, volume, length, malleability, melting point, hardness, odor, temperature, and a lot more. And I want you to make a scientific observation of the properties of water and oil, mostly based on your memory of what these look like. And then circle the ones they have in common and box the ones that are different. So ideas of properties are here. One of them that stands out to me is transparency. So right away I could say that water is clear and oil is clear. But making a scientific observation, I could also say slightly cloudy, but it's still clear. I can see through it, but it's a little cloudy. Another thing that I want to write is they're both liquids. My water, I could say no color. And our oil is yellow. Okay, now I think this is enough. We wanted to circle ones that they had in common. And box ones that they did not have in common. No color, yellow, slightly cloudy. Fantastic. All right. Now, with our oil and water example, we know that substances have different properties. We saw that. And that comparing these properties is one way to tell substances apart. We can see that water and oil have these different properties, but the real question is, we don't know what it is about these substances that actually gives them their properties. Why is oil yellow? Why is water clear? So that's what we're going to be investigating today. Why do different substances have different properties? So to start, let's watch a quick video.
Look at this butterfly. Ever wonder what it's made of? This butterfly, this picnic table, and this water are all made of atoms. Everything is made of atoms. Atoms are too small to see. They are so small that scientists can only make images of atoms using the most powerful microscopes in the world. Still, we know everything is made of atoms. Scientists use models like these to represent atoms. If you could observe things that small with your eyes, you could look around and see that all matter is made of atoms. For example, water is made up of atoms. This model shows atoms joined together in groups called molecules. Water molecules are made of hydrogen and oxygen atoms. What about this table? It's made of wood. But what type of atoms make up wood? Wood is made up mostly of hydrogen, oxygen, and carbon atoms. Even the air we breathe is made up of atoms. Air on Earth is made up of mostly nitrogen and oxygen molecules, and those molecules are made of atoms. Now when you look at the world around you, try to remember that atoms make up everything you see, even you. You're made of atoms too. Every single thing is made up of atoms and nothing else.
All right, so what does this video make you think about? One thing it made me think about was, one, atoms are very small. Another thing it made me think about is that it depends on how you look at an object that would determine what you actually are seeing in that object. For example, if you looked at a big scale, you might see the whole picnic table. But maybe if you use a microscope, you might see the wood grains in the table. But then if you even look even closer, you might see the atoms that make up the wood grains. This is scale, the relative size of things. Relative. So the scale that is visible to us, we call that a macro scale. But we also might use a micro scale for things that are too small to see without any tools. Atoms are so tiny that we need tools in order to even perceive them. One thing that you can do today is go to the HyperDoc link number 8. And there's this really cool tool where you can zoom in to different parts depending on your scale that you're looking at it. So you can go all the way out to the observable universe. You can go to Milky Way. You can keep going down and down and down, make your scale smaller and smaller and smaller, and eventually get to things that are smaller than electrons. And you can slide this back and forth and check that out. So check out this today. It's on HyperDoc link number 8. All right, next, what you're doing today and for the rest of this hour is you're taking a look at the handout that you got at the door, Atomic Zoom In. And I want us to remember how to annotate. So underline key phrases, star important ideas, circle confusing words or phrases, And annotate any comments or questions you have in the margins. Do a little stop and jot. When you're annotating, something that I like to do is anytime that I'm reading and I think to myself, really? That's a good moment to pause and write an annotation, either a summary, a question I'm having, something that just stood out to me, even a connection that we're learning in class. Great annotations look like this. They have lots of writing in the margins, lots of connection building, arrows, underlines, etc. When you're done reading the article, on the back, there are some summary questions. They're very straightforward. You kind of have to look back at the article to answer some of them. Others are just kind of your opinion. When you're all done with everything, hand in, and I'm sure I'll be back tomorrow. Link number 9 in the hyperdoc is the article. You can listen to it if you want to. You can grab some headphones. If you're using headphones, please return them and make sure they don't get tangled. Right now, they're all untangled and nice and ready to go. If you use them, please return them neatly how you found them. All right, that's it. If you have any questions, send me an email.